With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, in this question, a list of species having formula XZ4 in given below. We have this type of compound given to us and defining shape on the basis of location of X and Z atom. The total number of species having square planar shape is. Let's find out how many compound will give the square planar shape. So starting with the first option, we have XEF4. So let's find first hybridization. So for the hybridization, we will apply the formula which is half valency of central atom plus number of monovalent atom plus minus charge. All right, so this is a basic formula. So let's count how many number of valence electron it will contain. It will contain 8 electron in valence shell, so it will have 8, and monovalent number of monovalent atom is 4 plus 4, and charge is 0, so we'll use 0. Then it will comes out to be half into 12, it comes out to be 6, which means it will give the hybridization will be equal to sp3d2. All right, and the shape will be here we have xe, here we have f, and f. 4 atom will be in equatorial position and 2 lone pair will be in axial position. So this is the structure of this, and its hybridization will be equal to sp3, and shape is square planar. All right, so let's try the second one. Second option is SF4. So in this case, half valency of sulfur is 6 plus monovalent atom will be equal to 4 and charge will be equal to 0. In this case, we will get 5, which means hybridization will be equal to sp3d. All right, sp3d, and it will be, and let's draw the shape. Here we have sulfur, and here we have this type of 4 F atom will be there attached to sulfur, and it will give seesaw shape. All right, hybridization will be equal to sp3d and shape will be seesaw shape. And let's try the third one. In third option, we have SiF4. So let's find hybridization. Half valency of silicon is 4 plus 0. It will comes out to be 4, and it can say that sp3 means tetrahedral. All right, so let's draw the structure. Here we have silicon, and structure will be look like this: tetrahedral, F, and F. So shape is tetrahedral, and hybridization is sp3. So let's find fourth one. In fourth option, we have BF4 minus. Let's find hybridization. Half plus B will be boron, its valence electron is 3 plus 4, and there is a minus sign, so we will add here because it will gain electron. So we will add 1, then it will become 4, which means sp3 hybridization, and coordination number will be equal to 4, and the shape will be sp3, and the shape will be tetrahedral. Structure will look like this. Here we have this type of structure: F, and F. Negative charge will contain, and the shape will call tetrahedral. So let's draw the fifth one. BrF4 minus. So let's find hybridization. Half Br will have the valence electron 7 plus 4 plus 1. It will comes out to be half into 12. It will comes out to be 6. 6 means sp3d2 will be the hybridization, and shape will be square planar. Here we have this type of shape will be exist. Here we have 2 lone pair, and here we have F, 4 F atom in equatorial position. So this will be the square planar. All right, so let's see the sixth structure. So sixth compound will have the CuNH3 2 plus. CuNH3 2 plus. All right, so let's find oxidation state of copper. Here it will exist in +2 oxidation state. Then what will happen? It will give this type of configuration: 4s 0, 3d, 9. All right, this is a configuration of Cu2 plus. Then what will happen here? Here ammonia will act as a strong field ligand, but ammonia is not a strong field ligand, it is a weak field ligand, but this is exceptional case, so it will excite the electron and it will empty the orbital of d orbital. So here we have d orbital, and the electron will in this manner 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here we have s orbital, and here we have p orbital, and here we have one mass s orbital. This is a 3d, 4s, 4p, and this is a 5s. So what will happen? This NH3 is a strong field ligand, that's why it will excite this electron. It will excite this electron to the 5s, and it will become this orbital empty. Then this orbital will be empty for the ligand. All right, so it can donate its electron and it will use it as a hybridization. All right, ammonia will use this type of 4 ligand, one of the d orbital, dsp2 orbital it will use, and the filling of electron will be look like this: 1, 2, 3, 4, 5, 6, 7, 8 and 9 will be the in this orbital. All right, so this is our 3d and all the things we have. So the structure, the hybridization will be dsp2 and the structure will be square planar, FeCl4 2 minus. So Fe will exist in oxidation state will be equal to +2, and its electronic configuration will be equal to 4s0, 3d6. So we can say that in d orbital it will contain 6 electron, and here we have Cl is a weak field ligand, that's why it will not do anything. Weak field ligand, it will not pair up the electron as well as it will not excite anyone. So here we have 1, 2, 3, 4 any electron, it will not excite any electron. So 1, 2, 3, 4, 5, 6. So it will contain 6 electron. Here we have s orbital, here we have p orbital. This is a 4s, this is a 4p, and this is a 3d. So Cl ligand will use these 4 and it will become sp3 and the shape will be tetrahedral. Let's talk about the next. We have 8th option. In 8th option we have COCl2 minus, COCl4 2 minus. Cobalt will exist in +2 oxidation state and electronic configuration will be 4s0, 3d7, and d orbital will contain 7 electron, and here we have the same ligand Cl. It is weak field ligand, that's why it will not do anything. Weak field ligand, it will not excite the electron as well as it will not pair up the electron. So here we have 1, 2, 3, 4, 7 electron in d orbital, and here we have s orbital, here we have p orbital. So this ligand will use sp3 hybridization to make bond with CO. So the structure will look like this, tetrahedral with the shape. Let's talk about the last option we have PtCl4 2 minus, PtCl4 2 minus. So here Pt will belongs to 6th period element. So in this 6th period it belongs to 5d series. That's why this Cl will act as a strong field ligand. All ligand will act as a strong field ligand. There will be no strong field ligand, weak field ligand. So it will pair up the electron and it will give this type of configuration. Here we have 1, 2, 3, 4 s orbital and p orbital. So it will contain 8 electron in it. So what will happen here? Oxidation state will be equal to +2 and it will give this type of configuration. For electronic configuration is there, we have 6s0, 5d8. Alright, so d orbital will contain 8 electron, 1, 2, 3, 4, 5, 6, 7 and 8. And here Cl will act as a strong field ligand, that's why it will pair up this electron and we will get an empty orbital of d. So it will look like this: 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. the last orbital of D will be empty for the ligand, and this will be, so it will look like this. Here we have this type of ligand. So this Cl ligand will use these dsp2 orbital, and it will form a square planar shape. So let's count how many number of compound will give square planar. So starting with this, it will give square planar, yes, 1. Let's talk about this. It will give, yes, we have 2. It will not give, it will give, we have 3, and it will also not give, and the last option will give the square planar shape. So totally we can say that we will have 4 compound which are giving the square planar shape. The answer is 4. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.